Carrie and Sally, it's time. Let's go ahead and talk about all the logistics. Naomi's still coming, but I started recording for those people that are gone today, just in case they tune in at any point in time. I think everyone who's gone is AP's bio. Yes?
Yes.
Yes. Yes. Yeah.
Yeah.
Yeah. Okay. And then just Naomi's coming. And then, okay. Tomorrow, we have an AP. Okay, the gym. At 7:30, make sure you have your calculator. Make sure it is charged, or you have extra batteries and it's ready to go. Remember, if you bring any math stuff into the gym, it must leave on my cart. It cannot stay. Remember, last year was a bit chaotic. Don't go straight to the tables. Don't go putting things down because this is the second week of AP, so it's very possible that Mrs. Pratt is going to put your information form in a specific spot and you have to go find your name. So don't go over to the tables at all until she tells us that we can. So no, like setting up shop, it's not like the mock AP that way. And it is in the gym. I probably will be there by, like, set up, ready to go by 7, maybe 7:15. Note to self, get 2 boxes of donuts because we totally ran out, like, right away at the mock AP. Coffee cake, sadly, will not be there tomorrow. So I didn't have all the ingredients, but I did make banana bread. And coffee cake will definitely be there the day of the final for you guys at least. It just, I didn't have that extra stick of butter. But there's banana bread. I did that last night. What else? There will be a bacon breakfast steak and then a pepper one again. Or a green chili one, just because for my non-meat inclined people. Or non-bacon inclined. I know there are a few of you, but one of you's not in the class. I think that's about it. Today what I want to do is I gave you guys all the 2018 on Friday. So as far as where we all might be is 2018. If you guys have any questions, I would love just to kind of clarify. At the same time, I'm going to go over just a few things in your calculator because believe it or not, in some ways, if you've been working hard on studying, I fear for the AP content a little bit. Because I hope that you guys are studying Lagrange and Taylor's and Euler's and logistic growth and polar and parametric. Like, I hope that you're studying those things, but I fear a little bit for AP content, so I might go over just a quick little made-up, do you know how to use your calculator in the proper way, and et cetera, that I did with AB today. But I'm going to start off with if you guys have any clarification on 2018 that you would like, and then logistically, bonus is due today by 4 p.m. And bonus, by that I mean any practice exams or partial practice exams. I did have some AB kids that were absent today because they just wanted to stay home and study. So in some way, shape, or form, I suppose I will have to accept their bonus stuff after the AP. But I strongly advise, that means like in some ways there's kind of a window open for me still collecting some of that bonus stuff on Wednesday. But listen carefully, please don't stay up till 1 a.m. tonight pounding practice exams. Just get sleep after having put in some practice. And my advice to you, I'm going to show it up here on the screen, is not at this point to practice anything that you don't have solutions and or explanations to. Why? I don't want your brains hyperfixating on something and not being able to get an answer to it. Because then that's all you're going to be thinking about when you go into the AP tomorrow. So make sure if you do practice something, it's something with solutions that you can check. And to that end, I am right now in Khan Academy's AP Calculus BC. There have been years when he's done like live study sessions, etc., but he didn't this year. But what he does have is the 2017, 15, and 2011 and 2008 FRQs videos solved out. So that could be something where you try 2017, listen to his videos, or try 2011, listen to the videos about a certain topic or place where you might have gotten stuck. My just advice, if you are going to work, play with something. I would say play with something with solutions. Sound good? Okay. Besides that, I also wanted to show you, and I'm probably going to post it in Google Classroom. This is technically from 2014. But to be honest, BC doesn't change a lot. I mean, AB added L'Hopital's a couple years ago. Multiple choice questions added like definitions of integrals with the limit of Riemann sum notation. Besides that, there really hasn't been a lot that's been added in quite a while. So I liked how this would summarize the type of free response questions and what to be thinking about. I think that's helpful in the sense of some of you guys are freaking out about maybe like error or Taylor series. I like the quick summary that it had for that. I mean, area, volume. I like how it's talking about quick reminders with your calculators as far as stowing. Probably non-calculator with BC. I like polar equations. They're just quick summaries with parametric, with using Riemann sums. Anyway, I'm not going to go through every single one, but there are some nice with Eulers. There are some nice just quick little reminders that I thought might be helpful for you guys as far as thinking about the free response and the possibilities for free response. And some of this also talks about notation as far as the difference between at versus the value, etc., etc. Sign chart is not enough for justification. So anyway, I'm going to post that on there just because it's a quick little run-through of the possible free response. Now, I'm not going to say, I wouldn't stake my life that there couldn't be anything beyond the bullet points, but it does hit the highlights. So besides that, logistically, I think that's all I need to tell you. Besides, please don't be eating junk food all the way up until you go to sleep tonight. Please be hydrating today and in the morning. And please, yes, do get sleep tonight. Sound good? Study your forever's endeavors? Possibly? All right. If you guys don't mind, let me pray quickly for you guys today and tonight. Let's pray for your AP Bio compadres that are up there cranking one out, and then their brains are going to be a little bit fried just in time to study for tomorrow. Let's pray for them too, and then we'll get going. Sound good? Jesus, thank you for today. Thank you for this year and all that we have accomplished. It's brought us to today, the final class day before our AP. Thank you for not even just what you've accomplished in AP CalcBC, and it's kind of a culmination of AB and BC, but also these kids in their senior year and graduation coming so soon. As Nolani encouraged this morning, Lord, I just pray that you can open their eyes, our eyes, to the little blessings in each and every day leading up until graduation, and that we can take every moment, be aware every moment of the good, ignoring or brushing off or moving past the bad as much as is possible, giving grace and giving love where it is maybe not even deserved, but where it would be best for the other person and for ourselves. I just pray that in these last few moments before the AP and also the last few days before graduation, that this can be a blessed time for this class. Pray for our AP Bio kids that are up in the library and cranking out probably at this point. They've moved past multiple choice and are working on the rest and probably pretty close to getting done. Just pray that you watch over their minds that are going to be very tired and watch over them tonight. Pray for these kids before me that today's class period cannot be wasted but productive and helpful in a general sense and maybe a little bit of a specific one as well. Praise you for this test tomorrow and the ability that these kids will have to show what they've learned, hopefully what they've mastered, or at least what they somewhat understand. But God, I just praise you that your view of them, your plan for them is so much higher, so much greater than their ability or lack thereof in this class. And just pray that they can remember that even as they hopefully work hard to finish this part of their race well. Praise you for who you are and all that you've given. Watch over them tonight, protect, preserve, bring them into the AP tomorrow to be able to do their best on it by your grace and for your glory. In Jesus' name, amen. All right, so 2018, why don't you grab it out real quick. The ones that I printed off for you guys on Friday. Was anybody not here on Friday and didn't get them? Okay, I thought I got them for everyone. Everyone has the 2018? It was after your forever final. Yeah, it's the one that's like copied four pages to a side. Or sorry, 4 pages to a page. Yeah, I'll be here available until at least 4, if not 5, 6. Yeah. Number 1 had to do with the escalator problem. Number 2 had to do with vertical distances, infinite integrals, parametric motion. Number 3 had to do with kind of, given the graph of the derivative-ish, the accumulator function-ish with some increasing concavity points of inflection. It was an AB problem. Number 4 had to do with given a function, or maybe that was an AB problem. 4 might have been as well. Number 5 was polar area, and number 6 was Taylor series. Actually, it was a Maclaurin, but you guys know what I mean by power series.
Is there anything in particular that you guys want to talk about, talk through, think over, etc.? And remember, when you turn in your bonus practice exams, the full exam, graded, attempted, corrected, is worth 4 points. But even like a half, like doing your FRQs or doing, if you've only done one section of the other mock AP multiple choice, turn it in, you'll get a point, or you'll get 2, or you'll get 3, depending on how much of the exam is done. Up at the front, there is a period for paper for where all of your bonus stuff is to go by this afternoon. At least that's my advice. Once again, I technically will still collect it by Wednesday with so many people and AP being gone today. And the AP Bio kids, I'm not going to force them to come running down and turn their bonus in. So I will give the same allowances to you guys, but please don't stay up late. Okay, any of these FRQs you guys want to talk about?
Can you explain 1C?
1C? Yeah, this is one that Riley was talking about a little bit, or asked about a little bit, I think on Friday, or maybe that was not in class. That was in class. For 1C, we have to think about what would model, right? Before we figure out no people in line, we need to think about what would model the people in line for the escalator. This is an in-out problem in the sense that people are entering the line on this end, and on the other end, people are exiting the line to get on the escalator, right? So we have people going onto or into the line and people getting out of the line to get on the escalator. So we're trying to think about not the no specifically, but the people in line first of all, which I think you had to think about earlier than this. Between 0 and 300, people are entering the line according to this piecewise function. So the number of people in the line started at an initial of 20. So I could say the number of people in the line are going to be 20 plus the people that are entering the line between 0 and 300 at the rate of r of t dt. But in that time frame, we don't just have people entering the line, don't we also have people getting onto the escalator? So they're getting onto the escalator at a rate of 0.7. This is how many people are in the line up until 300. Now I could replace this with a t, but if I did, it would be for all the times in between 0 and 300. What you just did in letter B is that you figured out how many people are in line at 300, hopefully using this integration as net change formula. But here's the problem. You still have people in line at 300, which means in order to get to no people being in line, time must have gone beyond 300. And if time went beyond 300, well, there are no more people entering the line. So then I'd have to go ahead and say, how many people are in the line? I could do minus 300 to t. Even though there are no more people entering the line, there are people still getting on the escalator. So how many people were in the line plus how the number of people in the line changed, and 300 people entering, people leaving. And then I could say minus whatever happened after 300 up until what time would that equal 0. That's one way of thinking about it. The other way of thinking about it is, okay, if this is how many people are in line at 300, I need from 300 to t, I need that to equal, you could have it on the other side as well. But either way in your calculator, you should have already gotten this one from part B. And you're just going to set that equal to, technically not negative if you were setting it equal to, but 300 to t is right. And then just solve your answer.
Could you just do like the number leave over b minus 0.17 equals 0?
Well, that could tell you how much time it took, but remember that's from 300, and so they're asking for not how much time from 300, but you'd have to take that and add it. Because you're just going to get the change in time, not the actual time. But otherwise, I mean, I think you would probably logically make that.
Okay, so you just have to add it to
Just because, and this was in the, was it AB or BC? Oh, the ant and the snail problem. I don't think you guys did that, but it's a great one to look at. It's similar to the escalator problem, the ant and the snail problem from AB's mock AP. Where the snail was traveling and the ant started at a later time. It's kind of similar to the banana problem from a couple of years ago on the APs and the FRQs if you're looking at them. At a time later, the ant started off and then caught up with the snail. A lot of people went t is equal from 0 to, instead of realizing, no, the snail long story short, they are defining T to be the time from the beginning of the situation. And so if you say T equals like, I don't know, what's seconds? If you say T is equal to like 50 seconds and it really should be 350, they're not going to mark it right. You have to stick with their definition of T, which is the number of seconds at the beginning. Is that kind of be careful. Okay, Naomi, you had your hand up, kiddo. What else?
2C.
2C. 2 has to do with the plankton, right?
Mm-hmm.
We talked about the whole like B on Friday, but we didn't get to get any further. So we have that density up above. There we go. As modeled by letter C says there's a function in between 0 and who the heck is you? They haven't defined you yet, right? I don't see them anywhere. Okay, there's a function U. Oh, duh, they're explaining it. There's a function U such that U is like the upper bound between 0 and F. The upper bound of 0 and F. Whereas the improper integral from 30 to infinity of U of H dH, H has to do with the height or the depth you are in the sea. The column of water in part B is K meters deep, where K is greater than 30. Write an expression involving one or more integrals that gives the number of plankton in the entire column. Explain why the number of plankton cells is less than or equal to 2,000. Or, yeah, 2,000 million. Okay, so letter B, when we were solving this one on Friday, we were talking about, they actually give us a letter for plankton cells. Oh, keep running. Okay. Just in volume. They didn't specifically define it. And then we did from 0 to 30 of our area, which was 3 square meters times our P of H. We talked about why that was the expression, and you could just throw that into your calculator as far as millions of plankton cells. Okay. And then they say, as modeled by F, the density is modeled by, okay, F is the density after 30. To 100 is 1. So if F and P of H are both talking about millions of cells per cubic meter, this would be from 30 to infinity, meaning if this is the height or the depth, of the sea, they're saying from 30 to however deep the sea goes, which is kind of awkward. But it seems like a limiting constant in some way, shapes, or form. I'm kind of thinking logistic growth, but not really. I should be thinking convergence instead. The column of water in part B is K meters deep. Because they just said what's going on between 0 and 30. So it says as far as like the actual depth, that's K. So it's deeper than 0 to 30, right? An expression involving one or more integrals that gives the number of plankton cells, which we just did, but they want the entire column. I had to figure out where the difference was. There we go. So in letter B, they're saying just 0 to 30, and then it says all of a sudden it's deeper. Explain why the number of is less than or equal to 2,000. Okay. So if this is how we figured out how many plankton cells are between 0 and 30, what we have to figure out is, okay, well, how do we go even deeper? There's going to be more plankton cells, right? From 30 to how deep does it actually go? K. That's how deep it actually goes. We're still trying to figure out how many plankton, so we're still going to do 3, but why do I have to change the P of H?
Because it's only from 0 to 30.
It's only from 0 to 30, and so once we get past 30, I'm going to have to go ahead and use F of H instead. Because the density has changed. I'm still using 3 because I still have this clue, which they did not limit as far as only between 0 and 30. It said the entire vertical column has that horizontal cross section, so we can still use that. That right now would be an expression for the entire column. And if you don't know how to put it as far as like with variables, etc., you could just use words. Something to the effect of number of times in the entire column. You don't necessarily have to assign variables, especially because they haven't really given us them. But then it says explain why the number of plankton cells is less than or equal to 2,000 million. Well, we have an upper bound, right? And so we can say basically if f is bound by u of h, and if the integral from 30 to infinity, which is definitely less than, is 105, my guess is if you go ahead and take whatever the answer was, letter B, I think we could go check out the answer key, sorry. So at this point, we would just be plugging and chugging. It should end up being 2,000 million. Got it? Got it? Talk about the upper bound for all greater than. We could go ahead and say that this entire expression is bound by that guy. We could plug in. And then we take the number from up here, which is 1675. If we just plug in all of what they gave us in appropriate places, we get 1990 in a little bit. And we can say, oh yeah, that's less than 2,000. I mean, they just gave us a nice number to use. But all of it is basically like he's bound by him, and that integral is bound by that. So just kind of showing those inequalities and saying, sweet, let's go ahead and use that and say, yeah, he's on the upper end, and if he's on the upper end, add him to the other one. We're going to definitely be less than or equal to. Oh, it works, but it's just not good. See how they love playing with those different times and different heights and different bounds? And they're doing it more and more happy.
So I'm just wondering, like, what does each thing represent since you have to multiply by, like, the number? I didn't do this one.
You mean like 3?
So, yeah, so I just mean, well, not exactly 3, but you have to multiply, like, the 315 by the, or you have to add it? Oh, okay, so what do you
Because this integral, they said, is less than, no, equal to. They said this integral from 30 to infinity of u of h, u who's greater than the f of h that we're using, they said that was equal to 105. So we're just going ahead and solving the integral by plugging in, pulling out the constant, and then saying you're bound by this 105.
Oh, okay, so they just use, like, the number from before and add that.
And then they came back up here and said, okay, well, that's what happened here. Take the previous answer, and that's what this is.
Okay.
Does that make sense?
Yeah.
Yeah, there's a lot of throwing in stuff here and there in a very precise fashion, but still, yeah. Okay, any other FRQs we're going to? All right.
Could you look at 4B really quickly?
Yeah.
I thought I knew how to do it.
4 is polar? No, 4 is the AB one.
It seems really simple, but
B?
I thought it was just MBT.
It's either MVT or MVT IVT. Because when they say 2 to 10, H prime is equal to 2. If we just go between 2 and 10, which is what I would have naturally done, just seeing their bounds, that would have been 15 minus 1.5 all over 10 minus 2 is 8.
13.5.
Which does not equal to.
Yeah.
True.
Really.
So, if it's not a strict MVT, that doesn't mean that we can't still get the MVT. Meaning, we might have to use IVT and MVT. Doesn't MVT guarantee instantaneouses that equal averages? If we have to think MVT, IVT, what I need to see is an average that was greater than 2 and an average that was less than 2. Then I can say by IVT it had to go through 2. Just because this should be a twice differentiable function. Which means that H prime is continuous, which means H prime is also bound to IVT. Sorry, not even twice differentiable. Once differentiable would be H prime is continuous, so IVT applies to all the H primes. I don't see a big change here. That's not, well, I mean, that'd be less than 2, I suppose. My biggest change that I see, 5, 4, 3, 2 to 11. be 9. I need to see some sort of range. I think I would probably do here and here. Just because that's a baby change, which is going to definitely be less than 2, and I'm hoping this is a bigger change, which is going to be greater than 2. So I would look on the interval from 2 to 3, stating something about h prime needing to equal, and I could say a c if I wanted, for some c in between 2 and 3. 2 minus 1.5 all over 1, which is less than 2, which would be less than, I'm putting it in really messy notation just to get the idea across, from 3 to 10. I would have a guaranteed h prime of d, which would be 15 minus 2 all over 10 minus 3 is 7. So that'd be what? 13. Is there a bigger count? That's less than 2.
Did you just do 1.5 to 15?
So that'd be 13.
So
But if you do 1.5,
it's the, oh wait, that's still not greater than 2. 2.5 over 8.
I did press a bigger change, right? 2 to 6, 6 to 11, 2 to 11, 2 to 15. Huh.
Oh wait, 6 to 11 would be 5 over 2, right?
Oh, I wasn't looking at the changes in x. Yeah. So I just chose poorly. Five over 2 is more than 2. Yeah. There you go. So I could do 5 to 7. That would take me longer than I should. 11 minus 6 all over 2. There we go. So that'd be 2.5. That would be less than 2. So basically by MBT I have this. By MBT I have this, if I put it nicely. And then by IBT I have that. Lower than 2, greater than 2. The way that they put it. Hopefully using IBT and MBT, that's what I would have done. I'm not sure there's any easier way. Oh, they found one? There was one. Oh, I didn't even see it. I guess you could have tested them all. Which I probably would have ended up doing, but I was trying to shortcut the process and just picking it for you and going straight to the answer. But they found one where it actually was 2. But our MBT, IBT would have also worked, just would have been messier. But they would have just.
Oh my god, they're not.
They made it? Is there anywhere else we're going on? 1, 2, 3, 4, 5, and 6? Are they on break just now? No, they have to be done. Kathy.
For 3,
Yeah.
I was just wondering, on D, when it talks about the inflection points,
Yeah.
I was just wondering, like, if it's constant for a while for the graph of G, like, does that count as like a point of inflection if it changes, or is that?
G is the derivative of f. So for points of inflection of f, I'm looking at f double prime, which is G prime. Changing signs at zeros or DNEs. So I need a change in sign of G prime, which is f double prime, and the only place I see a changing sign. This is an interval, I get 1 to 0. But I couldn't use. I couldn't use this constant, Kathy, because if you think of like -1/2, right before -1/2 and right after -1/2, you see what I mean? There's no sign change. So the awkward thing, as far as points of inflection, before -1 is concave down, after 0 is concave up. Wow. Is there any singular point at where a change in inflection? Oh, G prime. Da 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 da. G prime. G prime is the slopes of G. The slopes of G changing from negative to positive or positive to negative, aka G changing from decreasing to increasing or increasing to decreasing, which only happens at 4. Double checking. Because G is constant and then positive, then constant, then positive, then constant, then decreasing. Sorry, G prime. Constant, increasing, constant, increasing, constant, decreasing. The only change I see is 4.
So it's like constant in between doesn't count as, well, like not necessarily like a point inflection, but like.
You're looking at it the way that I was looking at it, which was looking for a change in sign of G for relative max or relative min. We had to look at G prime to get F double prime. And so the only time that G is changing from decreasing to increasing or slopes are changing from negative to positive would be at 4.
Well, I was just wondering for like,
There would be no point of inflection there if this was the graph of G double prime.
or just for like the point 2, at like, I guess that's equals 2,
Well, at x equals 2, oh, sorry. I thought you got what I meant here. At x equals 2, at 1.9, it's 0, and at 2.1, it's 0.
okay, so that could mean like,
A point of inflection is defined to be a point at which the concavity changes, which means, I guess you could say infinitesimally close before and infinitesimally close after. Does that make sense? But just logically thinking, right before 2, right after 2, there is no positive negative. Does that make sense? And there are infinitely many points here and here. And so there's no point of inflection even though there's a change from increase to decrease because there is no singular point. At 1, it changes from increasing to constant. At 3, from constant to decreasing. So there is no singular point of change from that concavity change.
okay.
Does that make sense? Sorry, I thought you were here. Yeah.
So you don't count those that go like constant and then like they change through a constant. You don't count those as a point of inflection, or
Concavity, as a result of the constant portion, concavity has shifted or changed before and after that interval, but there is no point of inflection. Does that make sense? Yeah. There is no singular point of inflection. Yeah.
you do one.
D?
Yeah.
Yeah. So my justification or my rationale for finishing that at x equals 4 which changes signs at F double prime of 4 where Antibiotic, I'm glad you're alive and I'm glad you're breathing. I'm sorry that it might have been brutal, but so probably
Yes.
an incident? Hopefully not gonna be something to that effect. So Justin, just make sure that you make it a pip. So you have to have something about it equaling 0 where DNE at that point it will have a derivative. And then make sure you show its sign. You can also say something with words like G changes from decreasing to increasing. That would mean the same thing as G's prime. Alright, anything else 1 through 6? For those of you guys that came in, we're just kind of.
Wait, Misty, can you do 1? 1D?
Oh, you didn't say 3D?
Yeah. It's okay, thanks.
I wondered. I was like, that's awkward. We're just talking about it. Is this the one that we did on Friday? Huh. So it's between 0 and 300. Don't even have to worry about that. We already talked about number of people in line being 20 plus. You're going to go from 0 to t, right? R of, is that a t? Yeah. R of t minus the 0.7. That's the number of people in line between this. I want that to be a minimum, which means I need his derivative equal to 0 would be a knee, which is not going to be a knee, so equal to 0. His derivative, that would be just 0. That derivative, FTC part 2, would be R of t minus 0.7. Basically, when does the in equal the out rates? So you could go ahead and just throw in and find the zeros in between t is 0 to 300. So critical numbers.
Okay.
And then you're looking for a change in signs. And the cool thing is, I think on Friday, if I was talking about this one at some point, or maybe it wasn't with everybody in class, you could technically actually graph this, the R of t minus 0.7. You could talk about the sign change. You don't necessarily have to do testing the critical numbers and endpoints, minimum. They did critical numbers and endpoints, but I'm pretty sure that you could also talk about the behavior of R of t minus 0.7, about how it's going to be negative before 33.013 and then positive after. That could be an alternative justification, in my mind, a whole lot faster, because we could talk about the relative minute based on the behavior of the. No? Here, I can throw it in real quick. What is your R of? I'm going to go next to looking at the calculator anyway. For those of you guys that just came in, I did kind of just go ahead and talk through my advice for tonight, etc., on the video. See if you want to hear it. Or if people run out of questions. So if I were you, Justin, I would have thrown this guy into this dude.
Yeah.
I would have gone ahead and made my T-min, T-max to be 0 and 300. I would have made sure that I could see a little bit below, a little bit above. And as you do this, you should see. Is he still thinking? No, he's done. Oh, minus. My bad, Justin. That's R. We would have to go ahead and do. Well, it wasn't blurry a second ago. You're just done checking your stories? Yeah.
Wait, what?
I don't know. It's gone. Do you see it? I don't see it. Minus 0.7. There you go, Justin. That's what we want to see. So, Justin, negative?
Yeah. Yeah.
To...
Where it changed from negative to positive.
Oh, it worked on yours? Cool.
Oh, whoa, what?
I don't know. Mine was being funny. I might have plugged it in wrong because I was doing it fast.
I just did R minus 0.7. I found where it went from negative to positive, which is 33 point something.
Yeah. There you go. You got it.
I was confused at first because I forgot to put the minus 0.7 and there was no change.
Oh, yeah. That's what I just did, and I was trying to change it.
Okay. Well,
Christy, why don't you use the spinny chair? The green one. Up there.
That one's all bouncy.
Oh.